To show another video, this is from the 2017 PSLE Science paper. So, yep. What's up YouTube? What's up Facebook? What's up Instagram? Okay, I'm here to show another PSLE Science video. This video is going to be about the 2017 physical science questions. Okay, these are questions from my favorite book. This is the PSLE past 3 years questions book, which I've shown you in the previous video. Okay, so without further ado, I think I can make the video a little faster because the previous one I took about 45 minutes. I think I'm trying to cram it down to about 30 minutes, which is just about right, because every question by right you should take about 5 minutes to solve. Okay, so if you are taking more than 5 minutes, that's just a little bit too long. Alright, so without further ado, let's dive straight into the questions and take a look and see what the questions is being tested. So question number 1. Okay, so a metal lid was fitted tightly onto an empty glass jar. So Mary placed the lid in the hot water. After a while, she found it easier to remove the lid. Why? So you see, as I mentioned multiple times, it's always about explaining. So when it comes to explain, there is the start-end concept, which I like to use. Oops, sorry. Okay, what is the start-end thing? Big alphabets, yes. Start end. Okay, what I mean is the start end. So what we do is we fill in the start and then what is the start of this question? So the start of this question is actually about the hot water. So there's hot water in contact with the cap, and at the end is easier to remove lid. Why is that so? So we're going to try and explain. So of course, the hot water, what it does is that it expands the metal lid. Okay. So yeah, this is 1 mark. I don't have to write out the whole thing. I'm just going to type it out straight away. So straight away, we say that the hot water causes the metal lid to expand. Okay. Why? Because the metal lid gain heat. So what you can say, if you don't want to straight away go into the metal lid expand, we can talk about gain heat, or the metal lid gain heat from the hot water. The hot water causes the metal lid to gain heat and expand. Hence, it is less tight and easy. Okay, that's it. So the thing about gain heat and expand. Next one, let's continue. So next, when Mary took a cold, thick wall glass from a refrigerator and placed it in the boiling water, the glass cracked. Okay, so this is from the refrigerator. Cold, thick wall glass from a refrigerator. So is it hot or cold? It's supposed to be very cold when you take it out, and then you put it into the boiling water as shown. So the explanation is this, that the outside, which is in contact with the boiling water, expand faster than the inside, which is still cold. And this difference in the expansion caused it to crack. We actually saw this in 2016 paper before. Okay, so explain why. So the start end. Okay, so the start end, so the cold thick wall glass was placed in the boiling water. So when placed in the boiling, the glass gained heat and expanded. However, the cold part of the glass has not expanded as fast, hence the difference in the expansion, the rapid expansion, the fast glass to crack. Okay, so here the idea is that the one, once again, outside one in contact heats up, gain heat faster than the one that's inside. Okay, so it's a pretty not too difficult question to solve. Let's take a look at the next one. Okay, say the difference between evaporation and boiling. So there are several differences between evaporation and boiling. I'm just going to talk about one of them because they say state a different. So what we know is that evaporation takes place all the time, while boiling only occurs at certain temperature. Now we have to take note here. They're not talking about boiling of water. Okay, so if you are referring to boiling of water, or if you specify boiling of water, then the boiling point is 100 degrees Celsius. But over here at this point of time, we didn't specify that. Okay, so we just want to say that it occurs only at certain temperature. Next one. So we got this. Okay, this is a very common question. Okay, I've seen this multiple times. Okay, so it shouldn't be too difficult to do. Yeah, it's very standard. In fact, in a lot of prelim questions, I see this all the time. It's about evaporation, and the hole in the lid, basically the hole allows the water vapor to escape. Okay, so she observed that bananas in R became slightly wet after some time, but not those in S. So why the bananas in R became wet? Okay, so here the explanation is this: the hot water, because the bananas were hot, hot fried bananas. So the hot water vapor in box R came into contact with the cooler surface of the box and conducted water droplets, which fell onto the bananas. Okay, so this is for box R, but how about box S? Whereas in box there were holes to let the hot water vapor escape. Hence there is less condensation. Okay, so because there's less condensation, there's less water droplets coming down. Okay, so the concept is pretty easy, pretty simple. Let's move on. Next. Remember, I only have 5 minutes per question. Okay, so that is exam condition. Now, of course, it's not exam condition. I'm in a very comfortable place, okay, with my tea, which I just bought from the coffee shop. Okay, by the way, I just have about 1 hour before the next class starts. Okay, so I got some time. Quickly do one question. Okay, do one half a paper. Alright. Okay, so let's take a look at this thing. Okay, Ding Wei wanted to investigate how the number. Okay. So you see, as we become very experienced as we go along, a lot of the questions are like, I've said this before. This is about electromagnetism. Okay, and attracting the rods. You see, I haven't seen the question, but I'm just guessing. They are going to ask something about the power of the magnetism, because it's about the number of paper clips. So immediately what comes to my mind is number of coils, electricity, the number of batteries, stuff like that. Okay, let's see if that's what they're asking for. Oh no, okay, the first one is name one suitable material for the rod. Okay, so name one suitable material. Now, a lot of students will be very tempted to put magnetic material, but I think the answer should be iron. So you just say iron because you want to name one suitable material. You don't want to name one characteristics of the material. Next, suggest 2 reasons why the number of paper clips did not increase when the number of batteries was increased from 3 to 4. Okay, so the number of paper clips, as you can see clearly over here, did not increase. It remained at 6. So let's take a look at the setup. So the increase from 3 to 4, number of paper clips is still the same. The rest of the experiment is still the same. There is only one reason. The battery is flat. Yeah. Okay, so 2 reasons. So first reason, the battery, the additional battery is flat. Okay, hence it did not increase the magnetism. Next, another possible answer. So it's flat. Additional battery is flat. The number of coils. Okay, I think it can be the number of coils. I think we can say that the number of coils is already maximum, meaning the iron bar has already reached the maximum number of coils. Okay, I think it's something like that. So you see, it suggests two reasons. No, so you may be wondering, why didn't I explain? Because here is just suggest, so there's no need to explain. Okay, this is what I think it is. I'm going to take a look later, okay, whether it's correct or not. Next, Muthu performed an experiment on two different spring. What comes to mind? First of all, elastic potential energy. Okay, elastic spring force. So we have two different spring here. This is Q and the other one is P. What we can see is that the extensions are different. So for example, mass 100 gram, this extension is 2.9, this 1.9. What does this tell us? This tells us that spring P is harder. Just write a note here. This is a harder spring, or we can say that it has more elastic potential energy. Yeah. Okay. So just to make a quick note. That's for Q. Right. So based on the elastic relationship between the mass and the expansion of spring P, so we can see clearly that it is a direct relationship, meaning when the mass increases, the extension also increases. So this is a straightforward question. Let's just write down. As the mass increase, the extension of spring P also increases. Full stop. So for this type of question, there isn't a need for you to dwell too much about it because there's nothing much to think about. So what's the purpose of the pin? Alright, what's the pin? The pin is right here. This is the pin. Okay, I think the purpose of the pin is just to help us see, it's just to help us see clearly where the number is. So explain the purpose of the pin in the setup. This is 1 mark. I think it's just to help us, is to help or to ensure to ensure that the purpose of the pin is to ensure that a correct measurement is obtained so as to ensure accuracy in the. That's what I think it is. I think that should be the answer. Okay, I don't think the pin has got any science behind that. Okay, so Muthu used spring P to make a dish rack as shown. Okay, so how this thing works is that when they put the plates here, this part will go downwards. So as the plates are being removed, the spring will move upwards so that it's easier to collect the plate from the top. You don't have to go all the way down. Okay, so yeah, I mean at first glance it's a bit weird, like how does this work, but I think that's what it does. So when Muthu removed a few plates, the metal disc moved up from A to C. Name the main forms of energy of the metal disc at B. So the metal disc at B is here. So we got we got gravitational potential energy as well as kinetic energy. So gravitational potential energy and this is kinetic. Now why kinetic? Kinetic energy. Now why kinetic energy? So first of all, let's look at the question. The question named the main forms, meaning there are more than one. Main forms of energy. Gravitational potential, why? Because it's above the ground. And the what else? What else is that? Because Muthu removed a few plates quickly. So when he removed a few plates, clearly this thing will spring up. Okay, so when it springs up, it's moving. I will go with these two, gravitational potential and kinetic energy. Next, So Mutu changed all the spring to Q. He put the plates back on the metal disc based on the results. One difference Mutu will observe of the new dish rack when he removes the plate. Okay, so we gotta take a look at the other spring. At first it's spring P. So now I change to spring Q. I want to see what's so special about spring Q. Remember we talked about spring Q. So spring Q is harder. There's more elastic potential energy. So what does it mean when it has more elastic potential energy? Okay, so when Mutu removes the plate, what will he observe? Now, because the spring is so-called stronger or harder, you take off one plate, it's going to spring up faster. So Mutu will observe that the movement of the dish rack will be faster. Okay, specifically the upward movement. The upward movement of the dish rack will be faster. Why? So this is because spring Q has more elastic potential energy, which will be converted to more kinetic. Okay, so this is about conversion from elastic potential to kinetic. Okay, elastic potential to kinetic to more kinetic energy. Okay, so this is because spring Q has more elastic potential, which will be converted to more kinetic energy when the plate shifted. Okay, so this is my explanation as to why we will see the upward movement of the dish rack. To next one. Next is here. So John wanted to compare how fast a wooden block can move on different planks using the setup below. He released the block, measured the distance moved by the block down the plank and the time taken. I guess it's about friction. I'm just guessing. Okay, so and also could be gravitational potential energy. So wooden block will move down plastic plank. Plastic plank is smoother. Okay, so a shorter plank made of the same material as a plate. Will the block take a shorter, longer at the same time? So now we have the same material, but it's shorter. Now, if it's shorter, means that it's going to go like that. Okay, it's going to be something like this. So, is it going to take a longer or shorter time? So, obviously, it's going to be shorter. So, a shorter time will be taken to reach the bottom. Now the thing here is that we got to talk about in terms of energy changes. Okay, so this particular question is about energy changes. Why? Energy changes. So it's about I'm thinking in terms of friction. Okay, so I'm thinking in terms of friction because there is no change in the gravitational potential energy. However, what has changed is that the distance of the plank has changed. So the distance the block has to move decreased. Is less friction between the two surfaces. Now because there's more gravitational, so the gravitational, not more, so the potential energy will be converted to kinetic energy and less is used to friction. Is that you get the same amount of gravitational potential energy, which is at this point at the top, but now there's less friction. Now because there's less friction, you're going to get more kinetic energy. Okay, so less is used to overcome friction. So gravitational will convert to kinetic energy and less is used to overcome friction. Hence, there is more kinetic energy, which means it will travel faster. Okay, that's it. That's the main idea. Next, so John's results for plank R are shown below. John repeated the experiment with a wooden plank of the same length. Okay, so just now was plastic, now it's wooden. And move down the plank more. The wooden block move down slower. So which one shows the correct result for the wooden plank? Okay, so this is the plastic. Okay, so this one is plastic. Because it moves slower, right? It should take longer time. So the one that shows longer time, which one shows longer time? This is 2, graph L, okay. Yeah, this one. M. Okay, M is the one that shows it going down the same distance but at a longer time. Okay, so I would put M, graph M. Am I correct? Just to check. Yep, that's right. Okay, so graph M is correct. So besides the height and the length, state two other variables. I think the mass of the wooden block. Okay, so the mass of the wooden block is important. What else is important? The mass, the weight, the material. The mass, the weight. Okay, let's just put the mass, weight, and material of the wooden block has to be. Next, let's move on. Okay, so Polly wants to remove water from the ground using a water pump when it rains heavily. He uses the setup shown below to turn on the water pump. Okay, let's examine how it works. So this is one example of a question which I think it's going to take a while to understand exactly how it works. So let's spend some time to see how it works. Okay, so we got a water pump right here, metal sheet, wooden. The wooden block will make the metal sheet flow. Okay, I get it. So when water goes in here, when there's like more water coming in, the water level will increase. So as the water level increases, this thing will move up. The metal sheet moves. Metal sheet moves up. This metal sheet will come into contact with the two metal rods, causing the entire pump to be activated. And once activated, what does the pump do? The pump will, what does the pump do? Oh, they didn't, to remove water from the ground using a water pump. What does the pump do? So I think the pump will somehow, okay, it's not shown here, okay, but the pump will somehow remove water away from underground. Yeah, so it's not shown here. Okay, so here they didn't explain how the water pump will remove water, but we just want to see how the water pump will be activated. Okay, so this is the part where sometimes it gets confusing. Like students look at this, is like, yeah, I understand how this works, but you put one box here, you know, like, okay, this is water pump. You know, they don't really show exactly how the water pump removes water. So just ignore that part. Okay, so rainwater enters. State the property of rubber that allows the setup to work properly. So rubber is a poor conductor of. Rubber is an insulator and hence does not electricity to pass through. Okay, so it doesn't allow electricity to pass through, but how does it enable the thing to work properly? Because it doesn't allow electricity to pass through, electric current is not lost to the metal container. Okay, because if the electricity can pass through the metal container, here it will be a closed circuit immediately. So rubber is an insulator, does not allow electricity to pass through, and hence the setup remains and until activated. That's it. So we don't want it to be a closed circuit before it's being activated. Describe and explain how the water pump is turned on. Okay, so I just explained that just now. This is 2 marks. So we got to talk about from the right hand side. So when water, okay, I need to move this down a little bit. When water enters the metal container, okay, so we gotta start from when it rains heavily. Okay, so when it rains heavily, water enters the container and causes the wooden block to float upwards. The metal sheet will come into contact with, what do you call that? The two metal rods. Okay, it's called the metal rods. Causing a closed circuit which activates the water pump. That's it. Or turns the water pump on. That's it. Next, without using different apparatus, suggest one way to turn on when it rains less heavily. Okay, just use the longer rods. Use longer metal rods so that the wooden block does not have to float up a higher distance, right? Okay, so the idea is that we want the, you use something longer, this metal rod longer, so this wooden block will just need to float a short distance. So a little bit of water is going to cause it to float just up a short distance. And that's about it, I think. This is 2018. Yep. Okay, folks, ladies and gentlemen, parents, coaches, so that is all the 2017 physical science. We haven't talked about the life science. I think for 2017, there are less. Let me just... Okay, so I think for 2017, there are just less physical science questions so far. So once again, I think for this video, one of the key takeaways is that once you're very familiar with a lot of the questions, a lot of the questions, when I just look at it, I know roughly what they're going to talk about even before I read the question. So that comes with a lot of practice, a lot of exposure, and that is exactly what these videos are for. If you don't have the time, to coach, I'm assuming that you're a parent and then you're trying to coach your child to improve science. One of the things you can do, of course, is to show them this video, let them watch the video. So in these videos, I actually talk about all these different types of questions. So once your child is exposed to so many different types of questions, inevitably, they get so used to all these science questions, and inevitably, just by looking at the kind of setup, the kind of question, they already know what type of questions to expect. And because they have watched this video, because they have watched other videos as well, they know what kind of answer and what type of keywords to put in. Okay, so ladies and gentlemen, coaches, parents, this is how this video is useful for you. Okay, so if you like the video, if you like what we are doing over here, I'm actually doing this just before lunch. I got like a half an hour, 1 hour time pocket before lunch, so I just quickly do this video. I hope you can share this to other people who will find this useful as well. And once again, this is Mr. Ting signing on from the Serangoon Gardens branch of A Scorers. Thank you for watching.